Asha. So today we are going to discuss a topic named scalar potential function of a conservative field. So let us start with the definition. So if f bar is equals to gradient of phi and curl of f bar is equals to 0, then the vector field f bar is called conservative field. So whenever we want to check whether the field is conservative or not, we will check whether curl is 0 or not. And phi is called the scalar potential function. Okay, so let us understand this using examples. So we have to show that f bar is equals to 2xyz I cap plus x square z plus 2y j cap plus x square y k cap is conservative. We have to also find its scalar potential function phi. So firstly, in order to check whether the field is conservative or not, we will find curl of f bar, right? The formula is determinant of I, j, k del by del x, del by del y, del by del z, f1, f2 and f3, right? Now we know what is our f1, f2, f3. This is your f1, this is your f2 and the last is f3. So let us put those values in the formula. So these two rows will remain as it is. Now put the value of f1, f2, f3. f1 is 2xyz, f2 is x square z plus 2y and f3 is x square y. So now let us solve the determinant. So I times then minus j, right, plus k cap times this. So now let us solve from I. So we have to find the derivative of this with respect to y. So what will come? X square minus. Now we have to find the derivative of this function with respect to z. So minus x square will come. Done. Now we will solve from here. So find the derivative of this function with respect to x. So what will come? 2xy minus. Find the derivative of this with respect to z. So minus 2xy. And lastly we will solve from k cap. So we have to find the derivative of this with respect to x. So it will be 2xz minus. Now solve with respect to y. So it will be minus 2xz again. So you can see we are getting 0 I cap plus 0 j cap plus 0 k cap, which is equals to 0 bar. Therefore f bar is what? Conservative. Right? Now we have to find the scalar potential phi. So we know that f bar is equals to grade phi if our field is conservative. But we know the formula of gradient, that is what? Del phi by del x I cap plus del phi by del y j cap plus del phi by del z k cap. And our f bar is this, right? That is 2xyz I cap plus x square z plus 2y j cap plus x square y k cap. Fine. Now we have to compare on both the sides. Therefore, your del phi by del x will be what? 2xyz. Similarly, del phi by del y will be x square z plus 2y. And lastly, del phi by del z will be x square y. Now you have to integrate this, right, with respect to x on both the sides. So what you will get? Phi is equals to 2x square by 2yz plus. Now you are keeping your y and z as constant, so we will put f1 of y comma z because they are constant. Now these two will get cancelled out. Similarly, you have to integrate this with respect to y, keeping x and z constant. So your phi will be equals to, if you integrate with respect to y, your answer will be x square zy plus y square, right? 2 and 2 will get cancelled out if I put it, plus f2 of x comma z. And lastly, you have to integrate this with respect to z, right? So your phi will be x square yz plus f3 of x comma y. Now you have to write the terms for phi from these three, right? You have to write each term one time. So first write x square yz, and now one more term is that is y square plus c. In general, all the constants are written as c. So this is our scalar potential function phi. Okay. Now let us move on to the next example. Again, we have to show that this f bar is conservative and then find the scalar potential function phi. Okay. So now in order to prove that f bar is conservative, we have to again find curl of f bar. The formula is I, J, K, del by del x, del by del y, del by del z, f1, f2, f3. Fine. Now just put the values of f1, f2 and f3. First write I, j, k as it is. Second row also as it is. Now we know this is our f1, this is f2, this is f3. So put the value of f1, it is e raised to x cos y plus yz. f2 is xz minus e raised to x sin y. And lastly, here f3 is xy plus z. Let us solve the determinant. So now we have to solve this derivative. We have to solve this with respect to y. So answer will be x minus. We have to solve this with respect to z. So x minus x. Now minus j. We have to solve this function with respect to x. Right? So the derivative will be y minus. Now find the derivative of this function with respect to z. So again minus y will come. Now plus k. We have to find the derivative of this function with respect to x. So we will have z minus e raised to x sin y minus. Okay. Now we have to solve the derivative of this function with respect to y. So minus we will have e raised to x. Derivative of cos y will be minus sin y. So here what will come? Sin y, because we have already put minus. Now from here if I solve with respect to y, we will have plus z. Right? Now if I open the brackets, you can see these two will get cancelled out. So final answer will be 0 I cap plus 0 j cap plus 0 k cap. That is our vector 0 bar. Therefore, we can say that our vector field f bar is what? Conservative. Right? So now we have to find the scalar potential function phi. So we know that f bar is equals to grade phi if our f bar is conservative. So we can write this as what? F bar is what? E raised to x cos y plus yz I cap plus xz minus e raised to x sin y j cap plus xyz xy plus z k cap. This is equals to grade phi means del phi by del x I cap, del phi by del y j cap plus del phi by del z k cap. Just compare these two. Therefore, your del phi by del x will be equals to e raised to x cos y plus yz. Del phi by del y will be xz minus e raised to x sin y. And lastly, del phi by del z will be xy plus z. Okay. So now we have to integrate the first one with respect to x. Integrate with respect to x. So you will get your phi as e raised to x cos y plus xyz plus f1 of yz. Fine. Now you have to integrate with respect to y. So your phi will be xyz minus e raised to x, and integration of sin y will be minus cos y. So plus cos y plus f2 of x comma z. Lastly, you have to integrate with respect to z. So your phi will be finally x, y, z, right, plus z square by 2 plus f3 of x comma y. Okay, now you have to write each term one time in order to write the scalar potential function phi. So first we will write e raised to x cos y plus x y z. Now only which term is remaining? Z square by 2, and just write c as all the constants, right? So this is the answer of the scalar potential. Okay, now let us go to the next example. We have to just find the scalar potential function for f bar is equals to e raised to y plus 2z into I cap plus x j cap plus 2x k cap, right? So firstly, we don't have to find the curl here because we have to assume that this f bar is what? Conservative. F bar is a conservative vector field, right? Therefore, we can write that f bar is equals to what? Grade phi. Therefore, now open the bracket and write from this. So we can write it as e raised to y plus 2z I cap plus x into e raised to y plus 2z j cap plus 2x into e raised to y plus 2z k cap. This is equals to gradient, means del phi by del x I cap plus del phi by del y j cap plus del phi by del z k cap. Now compare these two, so you will get del phi by del x as e raised to y plus 2z, right? Del phi by del y as x e raised to y plus 2z, and del phi by del z as 2x e raised to y plus 2z. Fine. Now you have to integrate with respect to x on both the sides, right? So integrate with respect to x, so you will get your phi as e raised to y plus 2z is constant, so into x plus f1 of y comma z. Similarly, we will integrate, right, with respect to y. So your phi will be, this x is constant. Now the integration of this will be e raised to y plus 2z plus f2 of x comma z. And lastly, integrate with respect to z, right? So your phi will be 2x will remain constant, e raised to y plus 2z. Now your y is also constant, just do the derivative of this. So upon 2 plus f3 of x comma y. Now we have to cancel these two, right? So now just write a scalar potential function phi. Everywhere we are getting the same answer. So phi will be x into e raised to y plus 2z plus c. Okay? So this is the answer of the scalar potential. So now, how to find a scalar potential function? Firstly, you have to verify whether f bar is what? Conservative or not. Right? In order to check whether f bar is conservative, we have to check whether curl of f bar is equals to 0 bar or not. If curl is 0 bar, we have to write f bar is equals to grade phi. Now gradient formula is del phi by del x I cap plus del phi by del y j cap plus del phi by del z k cap. Now here f bar means f1 I cap plus f2 j cap plus f3 k cap. You have to compare on both the sides, integrate with respect to x, y, z, and find the scalar potential function phi. So phi is known as scalar potential. Okay. So I hope you have understood throughout the session. Thank you for watching.